Welcome to lesson 4-3. Today we're going to be writing and solving algebraic equations that involve addition and subtraction. To do this, we're going to take advantage of a couple concepts that we've already learned. First concept is that I can add the same amount to each side of an equation and the equation stays true. I could add, for instance, 2 to both sides of these equations and everything stays peachy keen. Likewise, I can subtract the same amount from both sides of an equation and everything stays equal. That is true. I can also multiply both sides of my equation by the same number and everything stays equal. And finally, I can divide both sides of an equation by the same number and everything stays equal. These we learned in previous lessons. The next concept we're going to use to solve these equations is the idea of inverse operations. Inverse operations undo each other. For instance, if I add 6 and then I subtract 6, I'm back where I started from. Addition undoes subtraction, and subtraction undoes addition. They are inverse operations. Likewise, if I multiply by 2 and then divide by 2, the division undoes the multiplication. Or I could divide by 2 and then double it, multiplying by 2, and the multiplication would undo the division. So multiplication and division are inverse operations. They undo each other. With those ideas in our back pocket, we're going to try and solve some problems. So George has plastic figures, and after he bought 7 more figures, he had 25 in all. And how many plastic figures did he start with before he bought the additional 7? Let's see what that looks like. Here's a balance showing what's going on here. We had the original amount of plastic figures n, and then he got 7 more, which I added 7 x's to that side, and that equaled 25. I put 25 x's on the right. So we'll write an equation also. So n, some number of figures, plus 7 more gave us our final 25. And we want to find out what the original n was worth. Well, if I have my balance here, I can take away the 7 on the left and then take away 7 on the right. So there they are. Taking them away, I'm left with n on the left, and I'm left with 5, 10, 15, 16, 17, 18 on the right. So I get n is equal to 18. In my equation, I can use inverse operations. What I did on the scale in the picture was essentially subtracted 7 from the left and subtracted from the right. And I know that if I subtract the same from both sides, my equation's still equal. And so plus 7 minus 7, those are inverse operations. I'm left with an n equals, and then 25 take away 7 is 18. Get the same answer with the picture as I do with the equation. Here's an example for you to try. Cabrini has some markers. We can call them whatever we want, use whatever letter we want. How about M? M equals how many markers at the start. And then she bought 12 more and had a total of 16. And we want to know how many she had at the start, what that M was. So we're going to want to draw a picture, make an equation, and then use some inverse operations to find out what n is. Oh, they used n, so we'll use n also. There you go. Here's a picture of the original situation. Some number of markers, n, plus 12 more, gave us 16. See if you can write the equation that matches that. And then look at the problem before it and see if you can solve to find out how many markers Cabrini began with. All right, let's look at this another way. Clive's 19 years younger than Josh. Clive is 34. Write and solve a subtraction equation to find Josh's age, which we'll call y. Let's do a bar model. All right, here's the basics. Clive is younger than Josh. How much younger? Well, he's 19 years younger, so I'll label there. Josh is Y years old, the mystery age. And we know that Clive is 34 years old. So now we got to write a subtraction equation. They asked for a subtraction equation. So looking at this, it looks like Josh's age, Y, take away 19, gives me Clive's age, which is 34. And so now I just need to solve this. Well, how do I get rid of a minus 19? What's the inverse of subtraction? Well, the inverse of subtraction is addition. If I take away 19 and then add 19 in, I start off with where I began. So I can do that to the left. If I do it to the right, I'm going to add 19 to both sides. I'm left with Y equals 53. So Josh is 53 years old. All right, Andy had some basketball cards, and after he bought 12 more, he had 48. How many cards did Andy have at the start? Let's draw another bar model. All right, so Andy had some, we'll call it N, basketball cards, and then he bought 12 more, and after he had done that, he had a total of 48. So what he started with plus 12 more is 48. So my equation would be N plus 12 is 48. Now you're going to think to yourself, how do I get that N all by itself? I want to know what N equals. And so what you would do is the inverse of addition. Adding 12 is subtracting 12. Do it to both sides and everything stays equal. And N is 36. Andy started with 36 cards. All right, in this next one, Vivian read 14 fewer pages than she was assigned to read. She
Shame on
read
you.
60 pages, so we want to find out how many pages P she was assigned to read. Let's do another bar model. All right, so here's two bars. One, the longer bar is what she was assigned, and the shorter bar is what she actually read. Don't let this happen to you. And so she basically read 60 pages, and that was 14 fewer than she was supposed to read, and we'll call what she was supposed to read P. And so P, how many she was supposed to read, take away 14, gives us what she actually read. So how do you get rid of subtraction? How do you undo subtraction? Well, you add. And so to get rid of my subtract 14, I need to add 14. I can do this if I do the same to the other side. So I get P equals 74. She was assigned 74 pages. Here's some straight up practice. I want you to solve each equation. You're going to find out what M equals in this one. You're going to find out what Y equals in this one. You're going to do so using inverse operations. Give them both a try, and we will talk about it in class.